You might look at oak trees and admire their strong, peaceful presence, but they're waging a silent war on everything that's trying to consume them. And they're taking no prisoners. Welcome to the Goodish news channel. I'm Ashley, and in a news cycle that's always finding new and creative ways to stress us out, I'm here to offer you a small distraction from the chaos. So go grab your emotional support beverage because we're going on a side quest. A tree's entire existence is being eaten alive. The leaves, the bark, the seeds, everything on it is food for something else. They can't run, fight, or call for backup, so how do they live for centuries? As for oak trees, they use several layers of defense against rodents, insects, and disease. And today I'm going to talk about 3 of those strategies, and each one's weirder than the last. Every spring, caterpillars hatch right at the same time as oak leaves emerge. The leaves are young, soft, and full of nutrients, and the timing is perfect for the caterpillars. It's not so great for the trees. For a long time, scientists thought that leaf timing was determined purely off of temperature. Warmer weather would result in earlier leaves. But there's some new research that shows that's not the whole story. When a tree suffers a heavy caterpillar infestation one year, it delays its leaf emergence the following spring. Now, this isn't some massive amount of time. It's actually only about 3 days. That doesn't sound like a lot, but it's enough to do a lot of damage to the caterpillar. Caterpillars hatch on their regular schedule, but the leaves are still locked into buds, which means there's nothing to eat. The caterpillar survival rate drops like a rock, and leaf damage is reduced by 55%. Not bad for a 3-day rest. The lead researchers in this study noted that this delay tactic is actually way more effective than when the tree produces bitter tannins that the caterpillars don't like to eat. And this is because it costs the tree far less energy. So the tree uses this weighted out method, and it turns out to be super effective. All of this was discovered through satellite data. Researchers observed over a 900 square mile area of Bavaria, Germany. And they did this over a 5-year span. They were actually able to track individual trees through this method, and they could see how they reacted year over year to these caterpillar infestations. So this delay tactic is on a tree-to-tree basis. But this next strategy involves the whole neighborhood. Underground, trees are connected through a network of mycorrhizal fungi. This is also known as the wood wide web. And I actually did a video about this last year, so I'm not going to go into terrible detail on it, and I'll link to that if you want to go watch it. But here are the basics. If a tree experiences some form of distress, whether that's drought or an infestation, it can send a warning message to surrounding trees. The message can be sent through the fungus that lives underground. And they can actually even trade resources through this, which is amazing to me. But this isn't just limited to underground. Trees can actually emit an airborne signal to other trees. And they do this by releasing volatile organic compounds. It's basically an airborne chemical signal. So if a tree is experiencing an infestation of caterpillars, it can send a warning message to other trees. This is kind of like your neighborhood Facebook page when it's door-to-door sales season. You know what I'm talking about. They can produce tannins and bitter compounds in their leaves before the caterpillars ever get there. And the caterpillars don't really want to eat it because it tastes disgusting. But there's another layer to this that I find absolutely fascinating. Oak trees can use these airborne signals to call for insect backup. The organic compounds attract parasitic wasps, which lay their eggs inside the caterpillars, causing them to die. The tree is recruiting airborne assassins. So before a caterpillar infestation spreads, a lot of times they're going into a forest that's already prepared. So the leaf emergence delay works year to year, and the wood wide web works in real time. But this last strategy plays out over years. Most years, oak trees produce a modest amount of acorns. This is enough to feed squirrels, rodents, birds, that kind of thing. But there's not much left over. And this keeps acorn-eating animal populations relatively low. But then every 3 to 5 years, something switches. Oak trees across entire regions produce huge amounts of acorns, resulting in a giant surplus. sometimes up to 700 pounds per acre in 1 year. This is called a mast year. The leading theory as to why is called predator satiation. And for some reason, that's a really hard word for me to say. So many acorns flood the forest that even a healthy animal population can't eat them all. The overflow gets buried by squirrels who forget where they've put them. Turns out they don't have very good memories. But that works out well for the tree because these forgotten acorns, they become the next generation of oak trees. I want to show you what this looks like, so why don't we go on a field trip? I live in the DC area, and 2025 was a mast year for oak trees, and there were just acorns all over the place, and there still are, to be honest with you. There's shells and tops everywhere. So this might look like just a weed, but it's actually an acorn that sprouted, and I'll show you what I mean. So that's an acorn that sprouted, and I've pulled out probably 50 of those at least over the last month or so. Going for a walk was a safety hazard last year. Acorns were falling all over the place. I got hit, my car got hit, I'm pretty sure my kids got hit. So if oaks produced this many acorns every year, the rodent population would grow to match it, and they'd eat pretty much all the acorns that were produced. So this boom and bust cycle is actually a strategy. Lean years starve the rodent population down. Then the mast years overwhelm it. Then the cycle repeats. But how do the trees coordinate this effort? Honestly, we don't really know. Leading theories involve weather cues like a warm spring triggering synchronized flowering, and possibly the same chemical networks that we talked about earlier. The synchronization research is ongoing, and I don't think that the trees are going to give up their secrets easily, which I don't think any of us are surprised by at this point. So these 3 strategies use completely different timescales and different methods, but they're all very, very effective. We tend to think that intelligence requires a brain, but oak trees are making a pretty good argument that that's not always the case. If you're looking for more good news in your life, be sure to check out this video right here. And if you enjoyed this video, please give it a like and consider subscribing so we can ignore all the bad news together.